Hello everyone, welcome back to the part 3 series of the convolution neural network. And till now we have seen transition from MLP to CNN, padding and stride, feature map and receptive field. So far we have seen our convolution layer picks a window of a given size and weighs intensities according to a kernel. Now our aim is to learn a model that will output a peak in intensity information in the hidden layer representation where our object of interest is present. But there is a problem with this approach since we have ignored the color channels. That is, apart from height and width, an image consists of three channels: red, green, and blue, which means that the images, instead of being a two-dimensional objects, will rather be represented as a three-dimensional tensor, which is characterized by a height, width, and channel. Now, height and width gives you the spatial relationship, and channel is a multi-dimensional representation to each pixel location. So it basically gives you the information of how much red, how much green, how much blue is present in that particular pixel. So that's the multi-dimensional representation, and hence this like uh, like today's topic is going to be um a multi-input multi-output channel. So we'll learn about that. So for now, an image can be represented as, like, say, 1024 cross 1024 cross 3 pixels. Now, it is a good idea to formulate a hidden information as 3D. Like, till now, for a particular spatial location, say this, we had a single representation, like 1, and here we have 33. But now, we want a vector of hidden representations corresponding to each spatial location. So, overall, it looks like matrices stacked on top of each other. So, like each of these feature maps, like this is a feature map and this is a feature map, now each will actually provide a spatialized set of learned feature for the subsequent layer. Say, for example, say a lower layer that is closer to inputs. Now, say this channel is specialized to recognize edges. This channel is specialized to recognize textures and so on. Now we need to make some changes, very minor changes of course, to the original convolution neural network hidden representation equation. So now see, this stands for the kernel, this for the input, this is your hidden representation. Now see your original, like the difference between the original equation and this is, this input has a channel information which is coded as C. These are the spatial information, height and width. Similarly, your kernel will also need to have channel information for the input here. And now D, this indexes the output channels in the hidden representations H. So now the equation looks like this. So the dimensions changes. So originally what we have seen before, it was a 2D tensor, and now incorporating channel information on both input and the hidden representation, we represent your kernel as a 4D tensor. How this calculation actually happens, so we have seen in the previous video how the calculations happen for a 2D kernel matrix. So this is what I'm going to show you this time. So suppose this is your kernel. Now for simplicity of representation, because we need to learn that step by step, that will be easier for you to understand how this is all happening. This is your original kernel. Say we consider that there is the input image has a channel of ci, dimension ci, and this is your height and the width information. Now your kernel also needs to incorporate that information. So now your kernel is ci cross kh cross kw. Now you might argue that here it is shown like the 0th dimension is the height information. Now here the 0th dimension becomes the channel information. So this is not a problem, it can be used interchangeably, and in fact we prefer to use this as the 0th dimension. And suppose we say there are three kernel channels, and the original the 2D kernel was a 2 cross 2 matrix. So how would this data structure look like? It would mean this is a 3D tensor now, okay? So this would mean that there are three 2 cross 2 matrices stacked on top of each other. So if this was X, we would have said there are X 2 cross 2 matrices on top of each other. So suppose this is one 2 cross 2, this is another 2 cross 2 matrix, of course, and this is another 2 cross 2 matrix. Now these three matrices, and by the way, the values contained in these matrices will definitely be different from each other, because we are trying to learn useful features from your image. So naturally we won't take similar similar 2 cross 2 matrices for weighing those pixel information. So now this will look somewhat like this. So these are three, like individual this rectangle stands for a 2 cross 2 matrix. Now we will learn about a multi-input and single output channel first, because that will help you understand how multi-input multi-output channel works. So for now, your H will have only I and J. D is 1, so naturally it can be ignored. So suppose we have taken, this is your input image, we have taken a 3 cross 3 matrix and your input has two channels. So naturally your kernel also has to have two channels, and we have selected a 2 cross 2 matrix as the kernel height and width. So this is suppose channel number 1, and this is channel number 2 in your input, and this is channel number 1 in your kernel, and this is channel number 2 in your kernel. So each like each channel of this input image will interact with the corresponding channel of the kernel. So 2 will not interact with this, or 1 will not interact with this. So now how the calculations happen over here? So I have just separated those kernels and input image information. Now suppose we are trying to gauge the information at this point, the first point. So naturally, as you have seen in the previous video, this is going to be the window. So now you have two channels. So you have two matrices, and as you can see, you have two sort of kernels for each channel, input channel. So now what happens here is, first, just as your previous video, this will interact with this, and suppose the output is X, and this kernel will interact with this window, and suppose the output is Y. What information gets to here is X plus Y. To elaborate, this is going to be 1 into 1 plus 2 into 2 plus 8 into 3 plus 5 into 4. So now this is your X, And now for here, it is 2 into 0 plus 1 into 1 plus 1 into 2 plus 7 into 3. So this is your y, and x plus y here is 73. Similarly, just as I have shown in the previous video, it will slide sideways, it will slide downwards, and the other informations will be calculated. So for all those cases, there will be one value over here and there will be one value from here, and those two values are to be summed up, and the final matrix looks like this. This is for a single output channel. This is multi-input and this is single output channel. Now what about multi-output channel? So what are the changes that are to be made? So first we need to create a kernel tensor for each output channel. Suppose this is the original your kernel tensor. For this is got Ci is the number of channels in the input image. Now we need to create a kernel tensor for each output, which means we need to concatenate them on all output channel dimension, which means now your kernel tensor looks like the shape of the kernel tensor becomes C0 cross Ci cross Kh cross Kw, and now C0 is the number of output channels. Next, what will happen is the result on each output channel is calculated from the convolution kernel corresponding to that output channel and takes input from all channels in the input tensor. Now I know this doesn't make a lot of sense here. So now suppose previously we had a 2 cross 2 cross 2 kernel just in the previous slide as you saw, and now suppose we have 3 output channels. So now this is a 4D tensor of shape 3 2 2 2. Now how will this look like in the first place? So as I have said, 2 cross 2 cross 2 means there will be 2 2 cross 2 matrices, and 3 cross 2 cross 2 cross 2 means there will be 3 such data structures, which means like as in the previous slide, your kernel looked like this and each was a 2 cross 2 matrix. Now there will be 3 such 2 cross 2 matrices. This is, and each of these will stand for one channel. This is for channel number 1, this is for channel number 2, and this is suppose for channel number 3. And just as I have explained previously, suppose instead of 3 there is x, which means that there will be x such structures for each kernel dimension. Okay, now let me show you how it actually works. So this is your input channel. Now this, as previously, it's a 2 channel input, and now you have 3 such kernel structures, and see it's color coded, which means this will stand for this output, this speech will stand for this speech output, and this kernel structure is for this channel. So each channel has its own kernel. Now the calculation will be same as I have shown in multi-input single output. So if you just consider this one, ignoring say this peach and yellow, this will interact, these two will interact with the corresponding channels, these kernel and the input image, and that will output this information. So This is going to be the window. This is going to be the window. So 0 into 0 plus 1 into 1 plus 3 into 2 plus 4 into 3, that is added with 1 into 1 plus 2 into 2 plus 4 into 3 plus 5 into 4, and that is, this and this will be added, and that gives you 56. Now coming to this one, now forget about this and this. For this particular output, the window remains the same, but you have a different kernel set acting on the image. So for each particular channel, the kernel sets will be different. For each like output channel, the kernel sets will be different, and that kernel set will be acting on the input image, and from there you will get the hidden representation for that particular channel. So I will highly recommend you to take a screenshot in order to understand how this works, and this can act as a homework. You can just go through it and you can just find out how the values are getting calculated. And if you have any problem with this, please let me know in the comments. And for the next class, I'll be taking up the pooling. So that was all for today. I think there is a lot of information that needs to be processed. So take your time, and thank you for watching.